Next, we'll talk about this water cooled chiller. You see the additional components in water cooled chiller. In water cooled chiller, this chill water cycle is same as air cooled chiller. But in water cooled chiller, you'll find two shell and tube. One is for evaporator and one is for condenser. And if you talk about evaporator side, the cycle is same as air cooled. So let me show you some images first. You see this like a complicated machine. Can you identify this two different types of shell and tube heat exchanger? Here heat exchanger, this is one shell and tube and this is one more, two shell and tube. And you'll find this multiple compressors, find the expansion. So same component, compressor, condenser, expansion, and the evaporator. But the condenser as well as evaporator both is of same shell and tube type. Now, can you identify which is condenser and which is evaporator in this image? Any guess?
Below one white, it is condenser and black is white.
Remember, we have a simple clue for this. Always the insulated heat exchanger is a evaporator. So you can find the insulation, the black insulation on above. So this is evaporator and this is condenser. And with the cycle also you can identify, you see after compression, this the pipe is connected to this heat exchange. So this must be the condenser. Apart from this green color pipe, most commonly in actual practice, this is for cooling tower. One is from the cooling tower and one is to the cooling tower. So with the different options you can identify, but without this piping also easily you can identify the insulated shell and tube is a evaporator. And the reason, because in evaporator you will find this cooling effect. No? So to avoid this energy losses, we require insulation for the evaporator. But for condenser, we don't require the insulation because this rejection of heat will add advantage. So you'll find two shell and tube. And because of this, you'll find three cycle in this. One cycle is what? The vapor compression cycle. Same. Compression, condenser, evaporator, expansion, you know all this. The second cycle is a chill water cycle, same as air cooled. And the additional cycle in this is what? Condenser cycle, which will connect to the cooling tower with a separate pump. And why the need of this cooling tower and how to cool the water which is used to cool the refrigerant, that I'll show you with the line diagram. Before this, some more images. You'll find the controls, you'll find the electrical panel, lot of things. And this the control and the valves and other details is very, very important. We'll discuss at the time of part 5 under the topic hookups or valve package. At this level, just I'm showing some preview of this. This pressure gauges, there's different valves. This is very, very important for interview point of view and for installation as well as for designing point of view. Designing point of view for pump selection, because all these accessories and the fittings will create a higher pressure drop. So that must consider at the time of pump selection. So as a design engineer or as a installation engineer, for both these accessories are important. So we have a separate detailed topic in part 5. So at this level, just we're learning how this system works. Okay, so let me proceed. We'll try to understand with the drawing. First of all, with this image, what are the additional components in this? First of all, this green color line is a condenser piping. So additional cycle you'll find. And this cycle from the chiller is connected to, you see, it's a cooling tower. And cooling tower is simple construction. Cooling tower is used to cool the air. And the concept is evaporative cooling, like air cooler. How exactly the cooling tower, that also we'll discuss. But you see, this water which is used to cool the refrigerant is going to cool back by using this condenser, and for that we require a separate cycle and separate pump. So this complete circuit is a condenser pipe with a separate pump. Apart from this, we require the makeup water tank also, because you see in the cooling tower continuously the water is going to evaporate because the hot vapor, the cooling tower is used to separate the hot vapor from the water, like in air cooler. So you see in air cooler also we required the supply of water. No? After 1 or 2 hours the level of the water decreases. Why? Because the water get evaporates, and evaporation means it will take the heat from the air, but in this case it will take the heat from the water which is going to collect at the bottom, nothing but evaporative cooling. So it will separate the hot vapor from the cool water. So let me show you with the line diagram. Here you see this side, this cycle is same as air cooled. what we already discussed. The secondary cycle is same in air cooled as well as in water cooled. But in water cooled, you see, you can consider this H2O in, and we can consider this as a cold water in, and out as what? The hot water out. Okay, and this water is responsible to pick the heat from the refrigerant, and you can see from the compressor, the refrigerant is entering in the tube in the shell and tube heat exchanger, and water in as a cold water. I'm not talking about, I'm not saying chill water. Chill water you'll find in this side. Here the cold water, which is used or which you can get from the cooling tower. Okay, so cold water in and extracting the heat from the refrigerant. And if you talk about the standard temperature for this cold water in, this is 81 degree Fahrenheit, and the return is 90 degree Fahrenheit. Okay, so you see that the difference is nearly 10 degrees. Even here in the supply return also, suppose 54 and 44, the delta T is going to be 10. And remember, this delta T will use at the time of pipe sizing. And based on this, for this side, we have conversion 1 TR equal to 2.4 GPM. This is just a preview, just remember this. And for this side, we have 1 TR equal to 3 GPM. And why this difference in the flow rate? I'll just give you the idea. The detail we'll discuss in part 5. Because you see, here in this heat exchanger as evaporator, we are using refrigerant to cool the water. And in this case, we are using water to cool the refrigerant. Okay. So to cool the water, to cool the refrigerant by water, we require higher flow rate because the specific heat of the refrigerant and water is different. No? The specific heat of water refrigerant is more compared to water. So if you use water to cool the refrigerant, we require more flow rate for cooling the refrigerant compared with the cooling the water by using refrigerant. This is one point. We have some more points. We'll discuss this more about this. At this level, just remember this conversion. So you see the hot water, again, in order to use again this hot water to cool the condenser, it will supply to cooling tower. And in cooling tower is going to be supplying the sprinkler form. And on the top, you'll find the fan. And you see fan will suck the air from here. And the air communicate with the water. And the hot vapor is going to separate from the cooling tower. It's allowing only the cold water to collect at the bottom. Nothing but evaporative cooling. Okay, so continuously the cooling tower is used to separate the hot water from the return line from this in this cell and tube condenser, and allowing this cold water at the bottom. And again, this cold water by using this pump, and this we can call as a condenser pump as per the cycle. Okay, and this is a primary pump or chill water pump as per the concept. Primary, secondary we'll discuss later. This is a chill water pump and this is a condenser pump. This condenser pump again used to circulate the water. And you see, continuously we are going to evaporate. We are going to separate the hot vapor from the water. No? So what will happen? The level of water will decrease. So we require the make a water tank or a supply from the plumbing float valve. Suppose if I'm supplying from the municipal from the low level, we require anyhow float valve is required. So float valve you find the tank as the water maintain the level, it will close. Anyhow, the detail we'll discuss later. So we require a make up water also to maintain the water level. So it means compared with the air cooled, the water cooled chiller required contains supply of water, right? And in case of scarcity of water, we cannot use this water cooled chiller. And this is one difference. We have other points also to discuss. Okay, so the cycle continues. So in this you'll find 3 cycle. One is a refrigerant cycle, second is a chill water cycle, nothing but secondary cycle, and the third is a condenser cycle in water cooled chiller. And for interview point of view, remember this is important. First question they may ask, what is chiller? Different types of chiller. The second question is different type of chiller, and the third question can be the difference between the air cooled and water cooled chiller. So got the idea, the difference between air cooled and water cooled chiller? So the difference is at condensing side, na? Rest of the thing is same. The primary cycle is same. The refrigerant cycle, this secondary cycle is same. But the difference is only at condensing side. So this is important. So for interview point of view, you must use this term condenser. In air cooled chiller, the condenser is cooled by using the air, means the outside air. And we are placing that unit completely outside the building. And in water cooled chiller, the condensing unit is cooled by using water, and the water we are going to supply back from the cooling tower. And remember, this complete unit we can place inside the building except the cooling tower. Okay, because cooling tower we cannot place inside the building because this is used to separate the hot vapor from the water. No? So except cooling tower, the complete unit we can place inside the building, and that we are placing in the plant room. And cooling tower can be placed outside the building or on the roof. But if you place the air cooled chiller on the roof, we can expect higher efficiency because air cooled chiller, the condenser is cooled by air, na? And if we place on the roof means as the wind velocity is higher on the roof, the condensation efficiency will improve. Or else in the open area, we cannot place in the closed areas. I'm talking about air cooled. Air cooled we cannot place in the closed areas or in the area with a limited wind velocity. If you place in the rooftop or in the open area with the high wind velocity, you can expect the efficiency. But under that also we have some condition. If the outside temperature exceed 40 degree centigrade, again the efficiency will drop. That we'll discuss at the time of the difference between air cooled and water cooled in this chapter 5 only. One more point, you see, this is also important point. For example, compare this chiller, for big project, if you use DX system, you need to supply the refrigerant for the entire FCU and AHU, no?
Yes.
And compressing that much of refrigerant required very high capacity compressor. Compare with circulation of water.
Okay.
Because water remain water only in the entire circuit.
Yes.
But refrigerant changes phase from gas to liquid and liquid to gas, and compression required. And compared to compression, circulation required less energy.
Yes.
Circulating water required less energy compared with the compression of refrigerant. Okay. This is also one point, but we have other points also to discuss. Yeah, can I proceed to next?
Yes.
Sir, regarding it is not relevant at this time, but when we are using the cold storage, at that time we are using this ammonia refrigeration cycle, and some I think chillers are used. At that time, the minimum temperature will not be more than 0 degrees Celsius when we are using the water.
Yes, no, it can be because we are using a brine, not only water. We're using brine solution, water mixed with the glycol or propylene. We have different chemicals, and that solution we used to call as a brine solution, and with that we can reduce the freezing temperature of water to -4 or less than that.
Okay, means still, in ice manufacturing they are using the brine solution.
Yes.
Okay.
Even in this also we are using, in this cycle also we are using this for n number of reasons. We are not using the normal water. We are using water with the glycol or propylene that we used to call a brine.
Even in air conditioning also?
Yes.
Means okay, glycol has that capacity to hold the temperature for more time, na?
Again, apart from this, for life of the system, if you use only water, like you see, normally in our car radiators we are using coolant, not just water.
Coolant.
But you see, coolant we are using to increase the life of that heat exchanger. But the coolant is not used to extract the heat. The water is responsible to extract the heat. Okay, if you use pure coolant in the car, that will not help to reduce the heat of the radiator. Water is must. With the water, partly coolant is required so that the coolant will help to not to damage that system.
To reduce the oxidation.
Yes. Okay, so next difference between the air cool and water cool. This is important for interview point of view also, and this will help you at the time of taking the decision. But you see, if you are a beginner or if you are means even experienced, you're not supposed to take the decision in actual practice. In actual practice, this decision is going to be taken by the senior mechanical or architect or the means in the meeting at the initial stage. But this point will help you to suggest at the time of at the initial stage of the project. Okay, and mostly this chiller system we are using for big project, not for small project. Can be used for small project, but generally you'll not find this except the special cases where the client is very much bothered about the running cost or based on the availability of the system, etc. Okay, so we have some important points to discuss related to the air cooled and water cooled system. Apart from this, you see one more point related to this water cooled chiller. we require this dosing plant also if required, if the water is not the potable water. It means a separate treatment is required to maintain the quality of the water so that it will not decrease the or damage the system. Okay, in some
We
projects,
need soft water, right?
pardon, soft water plant is required, a dosing plant. If you are getting a hard water in your location, then to convert into the soft water, like 2000 this TDS level is we can consider as a hard water. So to convert that hot water into soft water, a dosing plant or a softener is required. Or else what will happen, the life of the system will reduce. This also one disadvantage, but we have some more points. You see, this is important for interview point of view. You see in the list, the first point, if we talk about the difference between air cool and water cooled chiller, cooling medium you see we are using the atmospheric air in air cooled chiller. There is a major difference between air cooled and water cooler. In water cooled chiller, we are using water to cool the refrigerant. Next, heat rejection, release heat to the atmosphere, and here release heat to the cooling tower or to the water, which is used to cool that condenser again. Next, condenser fan you will find in air cooled, not for the water cooled. Cooling tower is not applicable for air cooled, is applicable for the water cooled. Water usage, typically low water consumption, because you see in air cooled chiller we require to fill the circuit one time. And apart from this, a small makeup water tank is required even for air cooled chiller also, because see some amount of water is going to come out from this air vents, automatic air vents, but very less compared with the water cooled chiller in cooling tower. Okay, so the consumption of water in air cooled chiller is very less compared with the water cooled, and continuous required of water in cooling tower in water cooled chiller. So if there is a scarcity of water or if the water is expensive in your area, then we are not suggesting this water cooled chiller. We are using air cooled chiller only. Okay. But if you talk about efficiency point of view, that depends on the condition. For example, you see first here in this case, slightly less efficiency compared with water cooled chiller. Here typical more efficiency due to the higher heat capacity. This is in general, because the density of water is much higher than the air. So water extraction, water heat extraction compared with the air is 4 times higher. Okay, so efficiency point of view, you can consider water cooled chiller is offering higher efficiency. But if the outside temperature throughout the year, say less than 35 degrees centigrade, in that case, air cooled chiller is more efficient. You see, the outside temperature is suppose take example of Bangalore or many cities in India or in Gulf. Not many cities in Gulf, but in Gulf also you'll find some cities the temperature throughout the year will not exceed more than 35 degrees centigrade. In that case, air cooled is a best choice. Why? Because air cooled chiller work efficiently when the outside temperature less than 35 degrees centigrade. If you exceed more than that, say 40 or more than that, in that case, what will happen? The extraction or heat extraction capacity by the air is going to reduce because we are using air to cool the condenser. If the outside air is hot, what will happen? The efficiency or the heat extraction reduces. In that case, water cooled chiller work efficiently. Okay, so this is also one major point to consider at the time of selection. If the outside temperature throughout the year less than 35 degrees centigrade, air cooled is the best option, or else you can suggest for water cooled. But that is not only one point, because in some cases the outside temperature is above, suppose it's 40 45 or more than that, but the scarcity of water, in that case there is no choice for the water cooled chiller. You need to compromise with the air cooled chiller. But if you have both the options, in that case you can take the decision accordingly as per the condition. Okay, now if you talk about maintenance, you can think air cooled chiller, the maintenance is very less compared with the water cooled chiller, because water cooled chiller cooling tower, and this cooling tower we are using, which is placing outside the building and deals with the potable water. So water means the chance of corrosion and the cleaning is required. And this cooling tower, all these components, so proper maintenance or regular maintenance is required compared with the air cooled chiller. So maintenance point of view, you'll find more maintenance in water cooled compared with the air cooled. Next, space point of view, Depend again as per the case. Water cooled chiller required space inside the building and partly outside. And air cooled chiller required space outside the building. So as per the type of project, if you have enough space inside the building, we can go for this water cooled. Or if you have enough space outside the building, the choice can be this. The choice can be this air cooled. Okay. Next, noise level may produce noise due to this condenser fan. I'm talking about the air cooled. And in some cases, this noise may create disturbance to the other building, the neighbor building. The neighbor building may be say a high class building or some government buildings or some authority. So in that case, there may be chance of objection. So you need to consider that. But water cooled, since it's inside the building, I'm not cooling tower. Again, cooling tower will create noise. I'm talking about this water cooled chiller inside the building. So in the plant room, so noise point of view, it will not affect to the neighbor building. Initial cost, obviously, for water cooled is going to be higher. You see, typically less initial cost. I'm talking about air cooled and water cooled, not compared with the DX system. So air cooled chiller costing is less compared with the water cooled, because you'll find the additional cycle in water cooled system. Application point of view, as we discussed at the beginning, this centrifugal compressor available with the water cooled chiller only. So for higher capacity requirement, we'll go with the water cooled. But for medium or large capacity, we can go with the air cooled. You see, common use for smaller to medium size application. And this smaller and medium compare with the water cooled, not compare with the DX system. Okay, small means don't think that I'm talking about a villa or a small office. Smaller or mid size compare with the large commercial or large industrial site. Water cooled, you see, for large size application and industrial process. Next, location flexibility, suitable for location with the limited access of water. As we discussed, if the scarcity of water, the choice is going to be air cooled. If the water is available, then the choice can be a water cooled chiller, considering the other parameters. Next, if you talk about environmental impact, again, this water cooled chiller, consumption of water compared with the air cooled. So air cooled is a good option if you talk about this saving of water. Next, efficiency, as we discussed. You see, efficiency may decrease in extreme hot weathers, but you see, even the outside condition is higher in temperature, like above 50 also, the water cooled efficiency, water cooled chiller efficiency is going to be good, because water remain water only, even above 50 degrees centigrade. But air, if the temperature increases, the air temperature also increases, the efficiency of the condensation decreases. The same point what we discussed. Okay, so there are some important points or comparison between this air cooled and water cooled, and important for interview point of view also, and this will help you to take the decision as per the project requirement. Now, if you talk about the capacity, you see, as we discussed, 7.5 to 600, you 1 unit for air cooled, but for water cooled up to 6,000 as a single unit. And the quick summary, you see, generally we are using air cooled when the energy costs are low and the water cost is high. This is one point. You have we discussed the other point also. And if we talk about water cooled, when energy cost is high and water cost is low, the water cooled we can suggest water cooled. So this is about the air cooled and water cooled cycle, just a cycle, but we have a separate part for this. In detail, we'll discuss about the other components and the accessories and the chill water pipe sizing, etc. completely in this part 5, you see, after completing this air side ducting. Pump selection also comes under this pipe sizing, chill water pipe sizing, hookups, etc. At the time, we'll get more detail about this. But if you know this concept, then part 5 will be easy for you, because in part 5, we are talking about this chill water side only. So done for tonight online.